See that?
Yes, I do. It is. I do see
Yeah,
it.
yeah. Maybe you can explain that image and your work around these.
I need to give you a bit of connecting information first.
Okay.
There's so many ways to find planets, but all the ways we have, remember we talked about bias, how the transit method favors planets that are close to the star. They have a high probability to transit. They repeat their transit many times. It turns out that all the methods that work right now, none of them can find a true Earth twin. It's so hard to find a true Earth twin because our Earth is tiny. It's 10,000 times smaller in area than our sun. It is 300,000 times less massive. It is 10 billion times fainter in reflected light.
Wow. And so
So
when you say a perfect twin, are we talking those stats specifically?
those stats, yeah.
Got it. In comparison to its own sun.
Yeah. And it takes
Got it.
1 year to go around our sun because that's our year, our orbit. And so imagine if you saw transit, you can't even see that tiny of a signal. But if you could, you're waiting a year and then another year, to see the signal repeat. So what you're showing is, just wait there for 1 second, okay? I'm going to grab a tool.
Okay. Great. I'll get this image back up. Oh, look at that.
This is related
The-
to the image you're showing. It is a 1% scale model of something we call star shade. And star
That-
shade, what you're showing there, unfurling, is a giant specially shaped screen. It would be 100 times bigger than this. And
Wow.
Starshade would have its own spacecraft, and it would formation fly with a telescope. And the goal of Starshade is to block out the starlight so we can directly see any planets around it. So the planet's not necessarily going in front of the star, it's orbiting the star, and we're going to block it out so we can see only the planet light enters the telescope.
And so you have to launch this out into space, fly it, and then eventually unfurl it when you're aiming it towards the planet that you would like, or the star that you would like to block, right? And then there's a very specific angle that you have to get. You gave an analogy once about water and what those ripples from the starlight would be like,
Sure, I can.
and how you could the depth of what it takes basically to get a clear potential image of a planet.
Right. And this image, it's not like a beautiful Apollo image of Earth. It's still just a point source. It's still just like a speck of light, but it's blocking out the starlight so we can see the specks of light, including an Earth-like planet that are out there. But before we get there, I just want to say this only unfurls a single time. It's all stowed so it can fit in a rocket and it gets launched, and then it will unfurl one time. And when it has to retarget to a new star, it will move across the sky, just all big and open.
Oh wow! So they're just out there right now.
They're not there now, but when it does
Oh,
get up there,
okay.
it's not going to fold up again because that's, could get stuck or what have you. But let me
I
explain
see.
what Starshade is. You might ask, why don't we put a giant circle in space, like a circular screen or a square screen? And the reason is, oddly enough, if you block out a star, like a point source of light, and then you take your image, you actually are going to have rings of light. You thought you blocked it out entirely, but it ends up you've got rings.
Mm-hmm.
And that's bad news, but that is something people, it's like an undergrad level experiment in physics. But what's happening is that light acts like a wave. And that starlight bends around the outside edges of if you had a circular screen in space. And that is like dropping a pebble in a pond. You see ripples, the waves. And those light waves, they're very bright. They're much brighter than the planet you're looking for.
So they're still way too bright. You've blocked out all the light from, not all of it. You blocked a lot of it, but there's still ripples of light that are super powerful that are still blocking your vision of the star, of the planets that could be there underneath it.
Yeah, and for example, the ripples of light are 100,000 times brighter than the planet you're looking for.
That's crazy.
So it's pretty crazy. So this very special shape people came up with mathematically in the 1960s. And what this special shape does is now the light waves, they're bending around these petals, this special shape, canceling each other out. And this would be like dropping a pebble in a pond. And now the pond is perfectly smooth, but all the waves are pushed to some outer edges. Wouldn't that be so crazy? Can you imagine like
that
dropping? And then there's no ripples, but around it, it's like super busy all around. And then in between, it's like super, super smooth.
Yeah, no, that'd be very crazy. You drop a pebble in a pond and all the ripples just happen at the edge and nothing happens in the middle. And you have
That's,
clear vision of whatever you want to see because the ripples aren't impairing your ability to see what's there. And
and,
so,
and people have demonstrated this at a very small scale. The one I showed you, people took that to Death Valley, to the desert, and they used it over a few kilometers, having like a fake planet and star, an LED, and then they had the star shade, that 1% scale, and then a kilometer away they had their telescope or camera. And they have demonstrated in a tunnel as well, an 80-meter long tunnel that was more controlled down to the levels required.
wow. Yeah. So, I mean, it's still ongoing and useful in so many different ways.
Development of Starshade is still ongoing, but it's an amazing tool.
And so it hasn't been deployed yet. Is that right?
It hasn't been deployed yet. No.
Oh, okay. Got you. When do they think Starshade might be? I mean, because what do you imagine? I mean, you imagine you'll be able to, I don't know, X-fold your ability to detect, exoplanets?
Well, it's really about detecting the Earth twin because there's many different ways to detect planets,
Hmm.
but going out there to find another Earth is very challenging. And Starshade, a lot of these big projects, they're really touch and go. And right now, Starshade, there's no concrete plan to launch it right now, but I see it as my job to advocate for Starshade to make sure that it does get up there and get its job done.
Well, fantastic. That's our job too. Then, like, we need to get Starshade going once again, back on the team. You
Yeah,
know, on the marketing team, on the business team, speaking to the right people. We need to get this Starshade out. We need to find Earth twins.
we do. Yeah.
This Earth, this times. We need something to root for.